Hello viewers, in this video lecture, today we are going to talk about the module Power Generation Technologies, in which we are going to learn about lecture 5, Basics Concepts of Power Generation. In the previous lecture, we have learned about proximate and ultimate analysis of coal. So viewers, today we will deal with the basic concepts of power generation. Here are the important topics which will be discussed in this video: power generation, introduction to power plants, history, generator's working principle, power system, types of generation, classification of power plant, sources of energy. Introduction of the basic concept of power generation. Electricity generation is the processes of generating electricity from sources of primary energy for utilities in the electric power industry. It is the stage prior to its delivery, that is transmission, distribution, etc., to end user or its storage using, for example, the pumped storage method. Electricity is not freely available in the nature. So, it must be produced, that is transforming from one forms of the energy to electricity. Production is carried out in the power stations, also called power plants. Electricity is most often generated at power plant by electromechanical generators, primarily driven by heat engine fueled by combustion or nuclear fission, but also by other means such as kinetic energy of flowing water and wind. Other energy sources include solar photovoltaics and geothermal power. There are also exotic and speculative methods to recover energy, such as proposed fusion reactor designs which aim to directly extract energy from intense magnetic field generated by fast moving charged particles generated by the fusion reaction. Phasing out coal fired power stations and eventually gas fired power stations, or if practical, capturing their greenhouse gas emissions, is an important part of the energy transformation required to limit climate change. Vastly more solar power and wind power is forecast to be required, with electricity demand increasing strongly with further electrification of transport, homes and industry. In electricity generation, a generator is a device that converts motive power, that is mechanical energy, or fuel based energy, that is chemical energy, into electric power for the use of external circuit. Sources of mechanical energy include steam turbine, gas turbine, water turbines, internal combustion engines, wind turbine, and even hand cranks. The first electromagnetic generator, the Faraday disc, was invented in 1831 by British scientist Michael Faraday. Generators provide nearly all the power for electric power grids. In addition to electromechanical designs, photovoltaic and fuel cells powered generators utilizes solar power and hydrogen based fuels respectively to generate electrical output. The reverse conversion of electrical energy into mechanical energy is done by an electric motor, and motors and generators have many similarities. Many motors can be mechanically driven to generate electricity. Frequently, they make acceptable manual generators. Dynamo's generator pulsing direct current through the use of a commutator. Alternators generate alternating current. Mechanically, a generator consists of a rotating part and a stationary part which together form a magnetic circuit. Rotor, the rotating part of an electrical machine. Stator, the stationary part of an electrical machine which surrounds the rotor. One of these parts generate a magnetic field, the other has wire winding in which the changing field induces an electric current. Field winding or field permanent magnets. The magnetic field producing component of an electrical machine. The magnetic field of the dynamo or alternator can be provided either wire windings called field coils or permanent magnets. Electrically excited generators include an excitation system to produce the field flux. A generator using permanent magnets is also abbreviated as PM, is sometimes called a magneto or a permanent magnet synchronizes generator, that is abbreviated as PMSG. Now let us talk about armature, the power producing component of an electrical machine in a generator, alternator or a dynamo. The armature windings generate the electric current which provides power to an external circuit. The armature can be on either the rotor or the stator, depending on the design, with the field coil or magnet on the other part. Now let us discuss bit about history of power generation. The fundamental principles of electricity generation were discovered in 1820s and early 1830s by British scientist Michael Faraday. His method still used today is for electricity to be generated by the movement of a loop of wire or a Faraday disc between the poles of a magnet. Central power stations become economically practical with the development of alternating current power transmission using power transformers to transmit power at high voltage and with low loss. Commercial electricity production started with the coupling of the dynamo to be hydraulic turbine. The mechanical production of electrical power began the second industrial revolution and made possible several inventions using electricity, with the major contributors being Thomas Alva Edison and Nikola Tesla. Previously, the one way to produce electricity was by chemical reactions or by using battery cells, and the only practical use of electricity was for the telegraph. Electricity generation at central power stations started in 1882 when a steam engine driving a dynamo at Pearl Street station produced a DC current that powered public lighting in Pearl Street, New York. The new technology was quickly adopted by many cities around the world, which adapted their gas-fueled street lights to electric power. Soon after, electric lights would be used in public buildings, in business, and to power public transport such as trams and trains. The first power plant used water power or coal. Today, a variety of energy sources are used such as coal, nuclear, natural gas, hydroelectric, wind and oil, as well as solar energy, tidal power and geothermal sources. Now let us discuss about power generation. Mechanical power refers to the rate at which work can be done. It is a power output as opposed to a power input. You can also see in the figure 1. The power input is referring to how fast the fuel energy is converted to power to use for the car. In contrast, the power output is how fast the engine can do work when receiving the power from the fuel. The rate at which an engine uses fuel is the thermal power. Mechanical power is how fast mechanical energy can be delivered to a system. Recall that power is a transfer of energy in a specific amount of time. Mechanical power is often measured in horsepower, although it is sometimes measured in watts. Some examples are the engine of a car, the engine of an airplane, using a crane to lift heavy things. If mechanical power is from heat engine like a power plant, it is limited by the second law of thermodynamics, and the maximum amount of mechanical power is given by the Carnot efficiency. Mechanical power of a wind turbine is also limited, although in a totally different aspect, by the Betz limit. Simple machines are idealized or lossless. This means they do not lose any energy in their manipulation of forces. Therefore, mechanical power is conserved throughout the duration of its output, and this allows them to be analyzed easily in terms of mechanical advantage. Now, let us discuss about introduction of power plants. A power plant is the assembly of systems or subsystems to generate electricity, that is, power with economy and requirements. The power plant itself must be useful economically and environmentally friendly to the society. The present session is oriented to the conventional as well as non-conventional energy generation. While the stress is on energy efficient system, regards conventional power systems like to increase the system conversion efficiency. The supreme goal is to develop, design and manufacture the non-conventional power generation system in coming decades, preferably after 2050 AD, which are conducive to the society as well as having feasible energy conversion efficiency and non-friendly to pollution. Keeping in view the Pollution Act, the subject as a whole can also be stated as modern power plants for power like electricity generation in 21st century. A power plant is an industrial facility used to generate electrical power with the help of one or more generators, which converts different energy sources into electric power. A power plant or a power generation station is basically an industrial location that is utilized for the generation and distribution of electric power in a mass scale, usually in the order of several thousand watts. They are generally located at the suburban regions or several kilometers away from the cities or the load centers, because they have disadvantage like huge land and water demand, along with several operating constraints like the water disposal, etc. Electricity is produced at some electric power plant. Some fuel source such as coal, oil, natural gas or nuclear energy produces heat. The heat is used to boil water to create steam. The steam under high pressure is used to spin a turbine. For this reason, a power generation station has to not only take care of efficient generation, but also the fact that the power is transmitted efficiently over the entire distance, and that is why the transformer switchyard to regulate transmission voltage also becomes an integral part of the power plant. At the center of it, however, nearly all power generating stations has an AC generator or an alternator, which is basically a rotating machine that is equipped to convert energy from the mechanical domain, that is rotating turbine, into electrical domain by creating relative motion between a magnetic field and the conductors. The energy source hardens to turn the generator shaft varies widely and is chiefly the energy source hardness to turn the generator shaft varies widely and is chiefly dependent on the type of fuel used. The whole world is in the grip of energy crisis, and the pollution manifesting itself, the spiraling cost of energy and unconfirmed due to increase in pollution as well as the depletion of conventional energy resources and increasing curve of pollution elements. It is commonly accepted that the standard of living increases with increasing energy consumption per capita. The Government of India has laid down the policy. It is imperative that we carefully utilize our renewable resources of soil, water, plant and animal to live with sustain our economic development. Our exploration or exploitation of this is reflected in soil erosions, floods and rapid destructions of our forest, floral and wildlife resources. The depletion of these resources often tend to be irreversible since bulk of our population depends on these natural resources. Depletion of these natural resources such as fuel, fodder and housing power plant. A power plant is assembly of systems or subsystem to generate electricity. The power plant itself must be useful economically and environmentally friendly to the society. Now, let us discuss a bit about heat. With the increase in body's temperature, molecules of atoms vibration increases. These vibrations are then transferred from one part of the body to the another. The measure of energy with which the molecules vibrate in a system is termed as heat stored in that object. As per the definition of heat, it is defined as the flow of energy from a warm to a cooler object. The direction of flow of the heat energy takes from the substances of higher temperature to the substances of lower temperature. This is because the molecules are vibrating faster and transfer their energy to the molecules vibrating slower. The vibrational energy is also termed as its heat content. The heat content in the body makes it hot or cold. A substance may be absorb heat without an increase in temperature by changing from one physical state to another. In the process of melting, the substance is changed from solid to liquid. In the sublimation process, the solid is converted into a vapor. In the process of boiling, the liquid is converted to vapor. Heat is a form of energy that can be converted into work. The amount of energy is expressed in the units of work. It is expressed in joules. Heat is a form of energy can be converted to other forms of energy. For example, in motorized vehicle, heat is converted to mechanical energy. In electric bulb, it is converted to light energy. In thermal power plants, it is finally converted to electrical energy. Let us take 3 bakers. First with cold water, second with hot water and third with water at normal temperature. If we dip our finger in the beaker 1, then in the beaker 3, then we will observe that the water in the beaker 3 is hot compared to that in a beaker 1. Whereas, if we dip our finger in beaker 2 and then in the beaker 3, we will observe that the water in the beaker 3 is colder as compared to that in the beaker 2. This shows that we cannot rely in our sense of touch to judge the hotness or coldness of something, and that is why the degree of hotness or coldness of an object is measured in terms of a temperature. Temperature is a measure of hotness or coldness of a body. Celsius or Fahrenheit scale or in Kelvins. Relations are established on the amount of heat added to taken out from a body. Now, let us discuss about generator. Generator are useful devices that provide electrical power during a power cutoff and prevent discontinuity of day and night affairs and activities or disruption in operation in different conditions and places. All a generator does is to convert the mechanical energy provided from an external source to electrical energy to provide enough energy for other appliances. It works based on Faraday's law of electromagnetic induction. This law says that wherever a conductor is put among a varying magnetic field, the electromagnetic flux is induced. There are different electrical and physical configurations of generator. This diversity in the configuration is for use in different applications. In the following section, we will elaborate on how a generator works, what different types it has, and what parts a generator consists of. To get more acquainted with the world of this amazing device, let's see the generator's working principle. First of all, keep it in the mind that a generator is not a device that creates electricity. A generator uses the provided mechanical energy or forces the flow of present electric charges inside the wires for its windings. This flow of electric charges makes the output electric current used for different purposes. To understand what a generator produces, it is better to consider a water pump. A water pump makes the flow of water but does not create the water flowing through it. In simple words, the generator generates electrical energy by capturing the power of movement and turns it into electricity by forcing electrons of external sources through an electric circuit. Generators are the same as electrical motors, but they work in reverse. As mentioned before, a generator works based on the principle of electromagnetic induction, introduced by Michael Faraday in the 19th century. This law says that when a conductor moves inside a magnetic field, the electrical charge are created and can be led to make a flow. Again, in a simple words, a generator is just a couple of rotating wire near or inside a magnet or a magnetic field that causes the electrical current. The example of a water pump is the greatest to understand what a generator does. Now let us discuss about power system. An electric power system is a network of electrical components deployed to supply, transfer and use electric power. An example of a power system is the electrical grid that provides power to homes and industries within an extended area. The electrical grid can be broadly divided into the generators that supply the power, the transmission system that carries the power from the generating centers to the load centers, and the distribution system that feeds the power to nearby homes and industries. Smaller power systems are also found in the industry, hospitals, commercial buildings and homes. A single line diagram helps to represent the whole system. The majority of these systems rely upon three-phase AC power, the standard for large-scale power transmission and distribution across the modern world. Specialized power systems that do not always rely upon three-phase AC power are found in aircraft, electric rail system, ocean liners, submarines and automobiles. The power system is a network which consists generation, distribution and transmission system. It uses the form of energy like coal and diesel and converts it into electrical energy. The power system included the devices connected to the system like a synchronizer, generator, motor, transformer, circuit, breaker, conductor, etc. The power plant transformer, transmission line, substations, distribution line and the distribution transformer are the 6 main components of a power system. The power plant generators the power which is step up or step down through the transformer for the transmission. Now, types of generation. Conventional type, for example, thermal, hydraulic, steam, nuclear, diesel, gas, etc. Like bulk power generation in terms of megawatt and kilowatt. It can generate high voltages. Its installation cost is more and running cost is less. Its synchronizes generator are used at constant speed, for example alternators. It transmits the power for long distances and then connected to distribution system. Now let us discuss a bit about non-conventional type, for example solar, wind, tidal energy, biomass, geothermal, etc. Its generation in terms of kilowatt and volts. It generates low voltages. Installation cost is less and running cost is more. It synchronizes generators are used at a variable speed, for example induction generators. No question of transmission of the power and only connected to distribution of power. Now let us discuss about classification of power plant. Conventional power plant are steam thermal power plant, diesel power plant, gas turbine power plants, hydroelectric power plants, nuclear power plants. Now let us discuss about non-conventional power plants. They are solar system, wind energy power system, geothermal energy, ocean thermal energy conversion, wave and tidal waves, thermoelectric generator, thermo-ionic generator, biogas, biomass energy power system. A power plant may be defined as a machine or assembly of equipment that generates and delivers a flow of mechanical or electrical energy. The main equipment for the generation of electric power is a generator. When coupling it to a prime motor runs the generator, the electricity is generated. The types of prime mover determines the type of power plants. The major power plants which are discussed are steam power plant, diesel power plant, gas turbine power plants, nuclear power plants, hydroelectric power plant, the steam power plant, diesel power plant, gas turbine power plant, nuclears are all comes into the category of thermal power plants because they convert heat into electrical energy. The sources of energy, there are mainly two types of sources of energy. Conventional source of energy, that is non-renewable sources of energy, and second is the non-conventional sources of energy, that is renewable source of energy. Now let us discuss a bit about conventional source of energy. These sources are finite and exhaustible. Once consumed, these sources cannot be replaced by others. Example include coal, timber, petroleum, lignite, natural gas, fossil fuels, nuclear fuels, etc. The examples are fossil fuels, nuclear energy, hydro energy. Have you not seen the filling of fuel in automobile? What are the fuels that are being used in automobiles? What are the types of sources of energy they are? Are they non-conventional? Fossil fuel is an invaluable source of energy produced due to chemical changes taking place in the absence of oxygen in plants and animals that have been buried deep in the earth's crust for many million years. Fossil fuels like coal, petroleum, natural gases are formed in this manner. These are conventional source of energy. Now let us discuss a bit about non-conventional sources of energy. These sources are being continuously produced in the nature and are non-exhaustible. Examples include wood, geothermal energy, wind energy, tidal energy, nuclear fusion, gobar gas, biomass, solar energy. The examples are solar energy, wind energy, geothermal, ocean, biomass. It is evident that all energy resources based on fossil fuels has limitation in availability and will exhaust soon. Hence, the long term option for the energy supply lies only with the non-conventional energy resources. The sources which give energy continuously and which do not deplete with the use of the non-conventional sources of energy. For example, energy from solar energy, bioenergy, wind energy, geothermal energy, wave, tidal and ocean energy. Now let us summarize today's video session. Today you have learnt about power generation, introduction of power plants, history, generator, generator's working principle, power system, types of generation, classification of power plants, sources of energy. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you.